This is a rolling body. It is moving on inclined plane. When a body is rolling down, we need to talk many things. Like we need to talk about acceleration of the body. We need to talk about linear speed of center of mass. We need to talk about what is the kinetic energy of rolling body. We need to talk about potential energy of the rolling body, and we need to talk about total energy of rolling body. In today's video, let us learn how to find out expression for linear speed of center of mass, and we will also find out the expression for acceleration of rolling body. This is the rolling body. When the body is rolling down from top to bottom, it suffers acceleration. So what is the expression for acceleration? And idea to find acceleration of rolling body. Here also I am going to help you. I am going to give you the idea how to find out acceleration of linear acceleration of rolling body. Here, as the body is rolling down, we observe the two things. At point A, the body moving slow speed. At point B, slightly the speed has increased, and from point B to C and C to D, the speed of the body, the rolling body keep on increasing. Implies a rolling body suffers acceleration. And second point, that is more important, that the yellow colored spot of rolling body, that is nothing but center of mass. So as the body is rolling down, the center of mass is moving in a straight line. We can clearly see that the center of mass of the body is moving in a straight line. So when a body is rolling down, the center of mass moves in a straight line, and when it is moving in a straight line, it has a kinetic energy, and the rolling body has a rotational kinetic energy. First of all, what is the basic information? The basic information is the mass of the rolling body, that is denoted by capital M, and it is an inclined plane. So we must know what is the angle of inclination. So theta is the angle of inclination of inclined plane with respect to horizontal, and r equals to radius. You see, this is rolling body, so this is the radius of the rolling body, and I equals to moment of inertia. When the body is rolling, there is a axis of rotation. You see, this is the axis of rotation, and body is rolling down, so there is a rotational motion. When there is a rotational motion, there has to be moment of inertia. So I equals to moment of inertia of the rolling body, and k equals to radius of gyration. So the relationship between moment of inertia and radius of gyration given by I equals to mk square. This is a relationship. So this is a basic information about the rolling body. And suppose V with the linear speed of center of mass, then linear kinetic energy given by half mv square, and it is rolling down, so it is a rotational motion. When there is a rotational motion, there has to be rotational kinetic energy. So rotational kinetic energy half I omega square, and I equals to mk square, and we know that V equals to r omega. Therefore omega equals to V upon r. Therefore in place of omega, I can write V upon r whole square, and total kinetic energy nothing but linear kinetic energy plus rotational kinetic energy. So this is equals to half mv square plus half mk square v square upon r square. If we simplify this and we take half mv square common, then it becomes half mv square 1 plus k square upon r square. So this is the total energy of rolling body. Now from the figure, this is the starting position, and it is the final position of rolling motion, and center to center distance equals to s, and from the figure sin theta equals to h upon s, so we get s equals to h upon sin theta. Call it equation number 1. Now the total energy, I already explained you how to get the total energy. So that total energy nothing but half mv square 1 plus k square upon r square. Call it equation number 2. Now here I have shown in the diagram that at the topmost position, when the body at rest, it has only potential energy. So at position A, the total energy is equals to potential energy, and at last position, when it is just touching the ground, it has only kinetic energy. It has only kinetic energy. So at topmost position, only potential energy, and at the bottommost position, only kinetic energy. And when it is middle between the topmost and bottommost, both the energies are associated with the rolling body, and the total energy at the topmost position equals to mgh. And when the body is rolling down, the total energy is not changing. It may change from one type of energy to another type, but the total energy remains constant, and the total energy of rolling body is also given by mgh. So mgh equals to half mv square 1 plus k square upon r square. Now cutting m both side here, m get cancelled both sides, so we get the twice gh. This 2 has come here upper side, so the gh, and here was 1 by 2 cross multiplication, so twice gh. So twice gh equals to v square 1 plus k square upon r square. Now we had here the 2gh. 2gh equals to v square multiplied by 1 plus k square upon r square. So this can be written like this: v square 1 plus k square upon r square equals to twice gh. So this term will go down and it becomes twice gh divided by 1 plus k square upon r square. Therefore we got v square equals to twice gh upon 1 plus k square upon r square. Taking square root, taking square root both side. So when we take the square root, v equals to under root of twice gh upon 1 plus k square upon r square. So we got expression. This is expression nothing but linear speed of center of mass when a body is rolling down. So we need to get the linear speed of center of mass. So linear speed of center of mass is given by under root of twice gh divided by 1 plus k square upon r square. Now we need to find out expression for linear acceleration. So the body is starting from point A. At point A, the initial velocity u equals to 0. So we have taken u equals to 0 as the linear initial velocity. And we are applying the kinematical equation, that is twice as equals to v square minus u square. So initial velocity 0, so in place of u square, putting 0 here, so we get here 2 twice as equals to value of v nothing but we got already under root of 2gh upon 1 plus k square upon r square. We can keep here square of it, and 0 square is 0. So twice as equals to twice gh upon 1 plus k square upon r square, cancelling to both sides. So we get here a s value nothing but h upon sin theta. So putting the s value here, h upon sin theta equals to gh upon 1 plus k square upon r square. H and h get cancelled both sides. So we get a equals to sin theta will go up. Therefore a equals to g sin theta upon 1 plus k square upon r square. This is nothing but expression for linear acceleration of rolling body. So when a body is rolling down, there is a linear speed of center of mass and linear acceleration of rolling body, and so we got the expressions here. What do you observe from these expressions? We observe that the linear speed of center of mass depends upon height, depends upon the gravitational acceleration, and depends upon the size of the spherical body. and linear acceleration depends upon angle of inclination. Angle of inclination changes, then acceleration of rolling body also changes. So these are the few observations for a rolling body on inclined plane.